Welcome to Study Loop.
Here in this question we have the top width. We can write it as A, which is equals to 1.5 meter. Then the bottom width, that is B, which is equals to 5 meter. Next we have a height of the water. We can write it as H, which is equals to 1 meter. Then the specific weight of masonry, we can write it as Wm, which is equals to 21.6 kilonewton per meter square. Then we have the specific weight of the water, so we can write it as WW, which is equals to 9.81 kilonewton per meter cube. Now we can find out the value of lateral water pressure, that is P, which is equals to the WW multiplied by height square divided by 2. Now we have all the values, so let's substitute it. 9.81 multiplied by 1 square divided by 2, so it becomes a pressure P, which is equals to 4905 kilonewton. Now we can also find out the total weight of this dome, that is W, which is equals to the A plus B divided by 2 multiplied by this WM multiplied by H. Now let's substitute all this value, that is 1.5 plus 5 divided by 2 multiplied by 21.6 multiplied by 1. So on simplification we get this value, that is 70.2 kilonewton. Now we can also find out the value of a centroid X. We can write down centroid X bar, which is equals to A square plus AB plus B square divided by 3 multiplied by A plus B, so it becomes 1.5 square plus 1.5 multiplied by 5 plus 5 square divided by 3 multiplied by 1.5 plus 5. So on further simplification we get this value, that is 1.782 meter. Therefore we can find out the value of Z, which is equals to the Z, if Z equals to X bar plus P divided by W multiplied by the H divided by 3. So let's substitute all this value. So Z equals to 1.82 plus P, that is 4905 divided by 70.2 multiplied by 1 divided by 3. So on further simplification we get this value of a Z, which is equals to the 1.806 meter. Now using this value of a Z we can find out the eccentricity, that is E, which is equals to Z minus H divided by 2. So this is 1.806 minus 1 divided by 2. So this becomes E, which is equals to the 0.64 meter. Now using this value we can find out the value of stress. Okay, so let's start with the first maximum stress. For the maximum stress we can write it as sigma max, which is equals to W divided by B multiplied by 1 plus 6 E divided by B. Now substituting all the values we can write this 70.2 divided by 5 multiplied by 1 plus 6 multiplied by 0.64 divided by 5. So we get this value of a maximum stress, that is sigma max, which is equals to 117.5 kilonewton per meter square. This is the first answer of maximum stress. Now we can find out the minimum stress, that is sigma minimum, which is equals to W divided by B multiplied by 1 minus 6E divided by B. So let's substitute all the values again. So it becomes 70.2 divided by 5 multiplied by 1 minus 6 multiplied by 0.64 divided by 5. So on further simplification, we get this value sigma minimum, which is equals to 78.8 kilonewton per meter square. So this is the second value of this question. The minimum and maximum stress both are the same or say comparatively different.